In this video, we are going to look at question 30 from the specimen paper. So in this question, a car accelerates from rest and reaches a speed of 10 meters per second after 5 seconds. And its mass is 1,000 kilograms, 1 ton. The engine exerts a force of 3,000 newtons, obviously in the direction of motion, while there also is a force of friction, drag, so in general a resistive force. But the force of the engine is still a bit bigger, so the resultant force points in the direction of motion, and therefore there is positive acceleration in that direction. And we're supposed to find this acceleration and also deduce the resistive forces which must act on the vehicle. So first of all, for the acceleration, we are going to use the most basic definition of acceleration as the change of speed per unit time, because we know that it reaches 10 meters per second from rest after 5 seconds. So 10 divided by 5 is 2 meters per second per second. That's the first part done. Now we are going to focus on the resultant force F. So if an object moves with a certain acceleration and has a certain mass, we can easily find the total force, or the resultant force, which must act on it by Newton's second law, which tells us that the resultant force must always be the mass times acceleration. 1,000 kilos times 2 meters per second, which is 2 kilonewtons. So we have 3 kilonewtons pointing in one way, and we also know that the resultant force is 2 kilonewtons in that direction. And they ask us about the resistive forces, the blue arrow. So that, of course, if F is 2 kilonewtons, the red force is 3 kilonewtons, then this must be 1 kilonewton. So the resistive forces amount to 1 kilonewton, and the combination of results, 2 meters per second and 1 kilonewton in the exam was option A.